There we go with the fourth review video. I told you I'd split it up so you don't have to watch the whole thing all at the same time. Because that's a lot of stuff. A lot of questions. All right. So here we go. I should be able to move this down. All right. So this is going to contain questions 31 to 40. Fast forward as you need to. Let's look at 31. I believe 31 is a graphing question. So there's 31 for you. And if you look carefully at it, it's -1/4. So I'm looking at something that is going to be very narrow. I'm already ignoring B to a point. Because see how it goes to 0, 1? I'm also considering that it's a negative cosine because it's -1/4 cosine. Usually the cosine function looks like a U. It has 2 periods, so I should be looking at 2 U's. Or in this case, 2 N's, because it's flipped around. It also has a minus pi/4 phase shift. So definitely no to D. And I'm considering saying no to C also. I think it's going to be A. Just look at it carefully if you were to graph this on a calculator. So for the sake of the example, let's go to y equals. I'm going to put in negative. Oh no, the calculator is going to yell at me. It has to use your little integer. Parentheses 1 divided by 4. Cosine. I have no idea what just happened, so bear with me. Cosine, I have to fit this. And it was, if I believe, 2x. More time. Negative, parentheses, 1 divided 4. Close parentheses, we want cosine. And we want 2x. And what was the other part of that? Minus pi/4. There's the calculator. I'm going to put in minus second pi over 4, close parentheses. All right, so if I were to graph this, and for the record, 2 things are happening here. The first thing is my stop plot is on, but that's not something you should have to worry about. I'm going to make my stop plot go off. I'm going to hit graph again, and you see a little squiggly line. I can't see anything, so I'm going to go zoom. And I want trig, so I'm going to go zoom 7. And now you can even trace it if you'd like. So for example, this is a phase shift that I'm graphing right now. If you notice that phase shift is about pi/4, and it has just 1. So 1 cycle, 2 cycle. Look at that. Okay, so you can definitely see there that it's example A or answer choice A. All right. Same thing with the cosine. This is -4 cosine. Is going to be a little bit more animated, and it is 2 pi x. So when you look at 32, this should look like, I haven't seen it yet because it's not A. Definitely going to be D. First things first, I want you to focus on the fact that that says 4 pi. And over here, this says 2 pi x. Also, the amplitude is -4. So it's an inverted cosine. Has to be this one. -4, the amplitude, +4, is definitely there. And you can also see that it starts at -4. It does have a slight phase shift, and if you count them out, you'll see that you have 4 of those cosine values. That is definitely answer choice D. If you still have trouble graphing with the graphing, do a little GeoGebra. That'll help you. Explore it on your own. Okay, this is a sine function. Again, another inverted sine function. On top of that, it has a negative vertical shift, the negative D shift. So number 33, let's look at the graphs. It's not A or B for sure. It's got to be C or D. And definitely C or D. And then let's look one more time up here. It's 2x and pi over 2. So I'm looking at this. This has to be the one with the phase shift. And it's definitely 2 rounds of this. So it's got to be C for the answer choice. You have to own this part of the lesson. Be able to graph it. You need to find your critical numbers. If you're looking at that and that does not make sense, start using all of the information I've thrown at you. I know I threw the kitchen sink at you, but you need to be able to graph that. Now 34 looks like a cosine. It has 3 cosines, a period of 3, and a phase shift. It looks like negative pi over 3. So I'm looking at, it's definitely not B. It's definitely not C. And it's definitely not D. I think it's for this one, I think it's gonna be, what are we on? 34. It's definitely A. And again, once again, you guys have to own the graphing. This is another one of these questions where you substitute and basically solve for the value. They're telling you that in January, your A value is 84 and B value is 43. So doing a little mental math, I'm thinking it's going to be 1, 2, 3. So the month should be March. And a little mental math puts me at 12,700 if you just simply add the two, 8,400 and 4,300. So pretty fairly easy. On 36, the tides question, we've done this one before. Between 5 and 11, somebody came and asked me this question earlier in the week. Let me see if I can get. Need to be able to see both. Okay. So first things first, you have a tide. And that tide is running between 5 and 11. So if I'm thinking of a tide, this is 11. Okay, H is 11. There you go. This is 11 a.m. here. And this is 5 as well. So it's ranging 12.8-hour period. So they're telling you the period is 12.8 hours. The range here, if I do 11 plus 5 and divide this by 2, I get 16 divided by 2, which is 8. So between 8 and 11, I'm looking at a difference of 3. Same thing for 8 to 5, a difference of 3. So we know our amplitude A is 3 for sure. We know we have a plus D because our D value, this is D right here. our D value is 8. So I've already narrowed my answer choices between A and D. B and C are no good to me. I also noticed here that it says the number of hours after midnight. So if you notice, they all have the same pi x 6.4, pi x 6.4, so that's not an issue. The issue is the phase. So here's what I know. I know that 12.8, the period, is equal to 2 pi over b. So if I swap them out, I get 2 pi over 12.8 is equal to b. Okay, so if I simplify this, I get pi over 6.4. That should be my, so in this case, pi x over 6.4 is your b term. It matches all of them, not a problem. The next question, oh yes, okay. So the next question is that it is a sine curve. So they all have sine curve. So we have so far A, B. Okay, 1 second. I have to pause for 1 second. All right, so let's get back to business. I should be here. And this is our graph. All right, so very good. All right, and I better be sharing my screen at this point, so I don't think I am. There we go, now I am. All right, wonderful. All right, so I went through with you with the A, the D, and the B value. Now the C value, if we do the math for the C value, you'll find out that the resulting value will be 6.8 over X. This is where it gets tricky, and you kind of have to pay attention to detail in the question. So the tide is increasing, decreasing. They're saying that the average depth is 8 meters. It ranges from 5 to 11, okay? And then the variation can be approximated by a sine curve. So the idea, as I'm thinking about the amplitude, is that there is a slight phase shift. I want to say of 6.8, and all I did was work backwards. By literally taking the C over B value. So if you do the C over B value for A, it doesn't pan out. But if you do the C over B value for D, it actually makes sense in the drawing. So if I were you, I would try to recreate that using our X1, X2, X3, X4, X5 points. And once you, even if you just do the X1, you'll have enough information to go from there. Let's look at D. The 37, I'm sorry. 37 actually, this looks like a sine graph to me. It looks like, well, they're all sine graphs, so that should make life even easier. You do have, it looks like it's going through 3 periods. Let's see. Only because if you notice that's negative 1/3, this is positive 1/3, so I'm thinking it's stretched out. It's gotta be, it's definitely not the fractional pi over 3. It's definitely not the fractional 2 and pi over 2. This is definitely going by increments. It looks like increments of some sort of 3, and the amplitude is definitely 2. You can see that C and D are not possibilities. So for example, in okay, so here, actually that would work. A and D would work for this. However, it's not a pi over 3 period, it's a 3 pi over X period. So If that's the case, then this is one solution, one period of that. All right, again, look at the amplitude here. You see how it's 2 and this amplitude is 2. These guys are 3s. B and C don't work because that amplitude is 3, that amplitude is 3. I'm also looking at where the X is. And I'm thinking that if this is one rotation of that item, they are definitely talking, in this case, about 3 pi. So that's just a little intuitive knowledge you need to show there. And this guy is an absolute value of -3. So if it's an absolute value, think of yourself walking on water. So first thing I'm thinking of is this is definitely inverted. So it has to be either B or D. You notice I don't bother talking about A and C because they're going through the x-axis and above it, above and below. This is absolute value, which means above the y-axis. So this likely, I'm gonna dare say, has to be, I'm gonna go with D on this one. Look at that, look at the notation. So it's +3, amplitude only. It is supposed to be a cosine. And it does have a shift of 1/2. If you notice there's a 1/2 x there, this does not, the B does not have a 1/2 x. It has to be answer choice D as in dog. Okay, let's look at 39. So cosecant, if you remember, cosecant is the inverse of sine. So you're simply going to graph the sine value. We're looking for a sine with a vertical shift of 2, so that will help you right off the bat. And right off the bat, looking at a vertical shift of 2, it's definitely not C. And it's definitely not D. Look at the y-axis and where they turn. Definitely not B, but I will say that with certainty, it's got to be A. So go ahead and graph y equals sine of 2x minus pi over 4 plus 2. And then you'll see that if you graph in a second y equals, so let's do that here on the calculator so you can see it. So in y equals, I'm going to graph sine because that's the inverse of I don't know why that's doing that. Hang on a second. So let me just do this. Okay, so sine parentheses 2x minus, I'm going to go with second pi divided by 4. And we're going to close out the parentheses. We're going to go plus 2. And let's go ahead and graph it. That's what that looks like. If you notice, it's just slightly up. And now what I'm going to do is I'm going to go back here and I'm going to graph 1 over sine in parentheses 1 divided by sine. And what that will do is that will give me cosecant. So 2x minus parentheses second pi divided by 4 and then plus 2. All right, let's go ahead and graph that. That's not right. That should be right above and right below. Go back, see what has to be fixed. All right, so let me try one little thing here because we don't have cosecant on the calculator. Maybe if I put parentheses around the 1 over sine. Okay. Double parentheses, one divide sign, let's try this, 2x minus, okay, the cosecants is getting a little nasty to do. That's why I like GeoGebra. So let's just look at GeoGebra real quick. What a great little free tool to have. I like GeoGebra Classic. So that's the one I'm going to use. And you can start to see what I keep telling you guys relative to be able to differentiate between the two. There we go. So I'm going to put in y equals what did I say, sine parentheses 2x minus pi over 4 plus 2. That's what that looks like. All right, in the second graph, I'm going to put y equals, call it y2. y2 equals cosecant parentheses, and we're going to do 2x. Do it again. But I haven't put in everything, so maybe that's what it is. 2x minus pi over 4. And then I have to put in the plus 2. There you go. See, that's what they're trying to graph there. Minus, they don't want you to see the sign. They're giving you this. But I want you to understand that behind it, there is a sign here. And so the key as well to this is that the asymptotes, the vertical asymptotes in this case are x equals. As one example, we could do pi over 2. That's one example. You can see it over here. So it's like an asymptote. You have another one here where x equals. So if I did x equals pi, it would sit right there. So these are vertical asymptotes that you do have available to you. And so there are vertical asymptotes of pi over 2, negative pi over 2, 3 pi over 2. They're all over the place for A. Okay? All right. So GeoGebra is your friend. Next one is a tan, actually cotan. So I want you to remember, let me close these out. So when you graph cotan, you're sitting between negative pi over 2 and pi over 2. Cotan is from 0 to pi, remember that. Okay, let me just open this up real quick. Okay, so I'm not saving it for the sake of getting my weekend on because I'm recording for this and I hope it helps you. So you have 3 cotan. And then in here you have parentheses x plus pi over 2. And that's what this looks like. You can see this. I'm going to go to move. Should be able to pull it down. This is quite annoying sometimes. There you go. So remember the cotan has a shape that looks like if you were adding a face, this is the face could be looking in the opposite direction over here towards the right, as opposed to tan. I'm just going to do plain old tan x. Tan looks like you're about to sit down. Don't forget the knees, which are just the 3/4 and 1/4 point. Okay. All right, so this is number, what number is this? 39. Okay, and 40 is just under the cotan. So 40, first of all, figure that 40 is going facing to the right. So everything else aside from A is facing the opposite direction. So it's either A or D. And I want you to remember that this is a pi over 2, negative 3 pi over 2. In this case, these are practically identical. Let's see what the differentiation is here. Should be the turning point for this. So I'm looking at it, amplitude of 3. So at 1, 2, 3, right up here, it should be turning, and these are, whereas these are not. These are turning at like 1 and negative 1. All right. All right. So I'm going to stop this video here. And again, study.